Krakatoa, unleashing the power of nature's fury. Imagine an explosion so powerful that it could be heard thousands of miles away. A sound so loud it shattered eardrums and circled the globe multiple times. In 1883, the Krakatoa eruption wasn't just a volcanic event, it was a force of nature unmatched in modern history. But what made this eruption so cataclysmic? Today, we'll dive into the science behind the fury of Krakatoa and uncover the secrets of one of Earth's most violent geological events. Krakatoa, located in the Sunda Strait between the islands of Java and Sumatra in Indonesia, is part of the Pacific Ring of Fire, a zone known for its intense volcanic and seismic activity. But Krakatoa wasn't just another volcano. It sat at a geological crossroads where tectonic forces were converging with devastating results. Explain the tectonic setup. Indonesia lies at the intersection of the Indo-Australian plate, the Eurasian plate, and the Pacific plate. This creates a hotspot of subduction where one plate is forced beneath another, generating intense heat and pressure deep within the Earth's crust. Highlight Krakatoa's unique volcanic nature. Unlike shield volcanoes that produce slow lava flows, Krakatoa is a stratovolcano. These types are infamous for their explosive eruptions, thanks to thick, viscous magma that traps enormous amounts of gas under pressure. The build-up to catastrophe. Before 1883, Krakatoa had been relatively quiet for centuries, but in May of that year, the volcano began to awaken. Seismic tremors and minor eruptions signaled that something massive was brewing beneath the surface. Discuss magma chambers. Beneath Krakatoa, a magma chamber was filling with molten rock, gases, and extreme pressure. Over time, the magma's volatile components, water vapor, carbon dioxide, and sulfur dioxide, created a ticking time bomb. Show how the conditions worsened. By August 26, 1883, the pressure had reached a critical point. When the eruption began, it set off a chain reaction, triggering multiple explosions that culminated in one of the most powerful eruptions ever recorded. The Day of Fury. August 27, 1883, the day nature unleashed its full fury. 4 massive explosions tore through Krakatoa, obliterating 2/3 of the island and ejecting an estimated 25 cubic kilometers of rock, ash, and pumice into the atmosphere. The physics of the explosion. The sheer force of the eruption was the result of rapidly expanding gases breaking through the magma. Scientists estimate that the energy released was equivalent to 200 megatons of TNT, over 13,000 times the power of the Hiroshima bomb. The sound wave. The 4th explosion was so loud that it was heard over 3,000 miles away in places like Australia and Mauritius. The sound wave traveled around the globe multiple times, making it the loudest sound in recorded history. The aftermath. Krakatoa's eruption wasn't just a localized event, its impact was felt worldwide. Tsunamis. The explosion generated massive tsunamis, some reaching heights of over 120 feet, devastating coastal areas and killing over 36,000 people. Ash clouds and global cooling. The eruption sent millions of tons of ash into the stratosphere, blocking sunlight and causing a significant drop in global temperatures. The following year, 1884, was known for vivid sunsets and a volcanic winter. Sulfuric acid aerosols. The ash and gases formed a layer of sulfuric acid in the atmosphere, altering weather patterns and inspiring artistic depictions like Edvard Munch's The Scream. The legacy of Krakatoa. Krakatoa's story didn't end in 1883. In 1927, a new island began to emerge from the caldera left by the eruption. Named Anak Krakatau, or Child of Krakatoa, this island continues to grow and occasionally erupt, reminding us of the region's volatility. Explain ongoing research. Scientists study Krakatoa to better understand volcanic behavior, improve eruption prediction models, and mitigate future disasters. Krakatoa's eruption was a stark reminder of the Earth's raw, untamed power, a force that shapes our planet and our lives in profound ways. What other secrets does our planet hold, and how can we learn to coexist with such unpredictable forces of nature? If you enjoyed this journey into the science of Krakatoa, don't forget to like, subscribe, and hit the bell icon to explore more about the wonders and dangers of our incredible planet. Let us know in the comments, which natural phenomenon do you want us to dive into next?